Here the questions say in Meldes experiment it was found that the string vibrated in three loops. When 8 gram was placed in the pan, what mass about the place in pan to make the string vibrate in the 5 loops? Neglect the mass of string. Okay. Here the first of all here we discuss about to be the Meldes experiment. What is the Meldes experiment? The Meldes experiment is related with to be the its electric vibrator tuning fork. When tuning fork is placed on this table, you are observing this is a table, and this is the tuning fork is connected to be the electrical vibrator. It means here the one generator is connected to be the DC charge supply, and it connected to the DC charge supply. This is connected to be the DC charge supply, and when the DC charge supply to connect with to generate electrical generator motor in produced to be the vibration on tuning fork, and it connect with to the string is produce the oscillation, and this oscillation is transverse oscillation. Okay, here we say that transverse oscillation, and it produced to be the transverse oscillation, and it then connected with to be the second end is connected with to be the weight, and this is the pulling. So now we already know that downward direction is weight equal to mg, and upward force always act to be the tension force. So tension force act here the two side, the one is string on the string, another this is a T1 and this is equal to the T2. According to this figure, the Meldes experiment, it was found the string vibrating 3 loops. How many loops? 3 loops. The eta equal to 3 loops. N equal to. When mass is given is what? Mass is given to 8 gram in the pan. What must be placed in pan to string vibrating 5 loop if the eta 2 equal to 5 loop, n1 equal to 3 loops? So how many mass? In these conditions we neglect the mass of string. Okay, so now let's we prove the answer. First of all, here we in Meldes experiment, here the mention about the string, so that's why we discuss about probably the transverse wave, transverse oscillation. Okay, two type of the wave already you know, the one is longitudinal and second is transverse. Here we discuss about transverse oscillation. So transverse wave, the what is the formula of longitudinal and transverse? Here the I discuss about the longitudinal formula is V equal to the constant eta upon L under root T by M. But why we said about the transverse oscillation in Meldes experiment transverse oscillation, according to this experiment, transverse wave V equal to eta under root upon twice L under root T upon M. So transverse waves V equal to constant, therefore nu equal to frequency eta upon 2L under root twice upon M. Therefore we compare to this equation, n1 upon 2L under root T1 upon M equal to n2 upon 2L under root T2 upon M. So 2L both have same value, so that's why we deduct 2 together. Therefore the eta 1 under root T1 upon M equal to n2 under root T2 by M. So in this condition you are observe the M are equal in both sides common, so that's why we concept first of all what I do that both have the n1 square T1 upon M equal to n2 square T2 upon M. Therefore, mm cancel. Therefore, n1 square upon n2 square equal T2 upon T1. Okay. Therefore, but n1 equal to how many? According to this equation, n1 equal to 3 and n1 n2 equal to 5, where T1 equal to 8 gram and T2 equal to we find. So therefore, T2 equal to, what is the value of equal to? T1 multiply n1 square divide by n2 square. Therefore, T2 equal to, what is the value of T1? 8 gram. 8 gram multiply n1 square 9 divide by n2 square 25. Therefore, T2 equal to 72 divide 25. Therefore, T2 equal to tension force. T is a tension. Tension act on second particle, second direction. T2 equal to 72 divide 25. Your answer is 2.88 gram. This is your final answer. Okay. Thank you.